All right, search in a rotated sorted array. Second problem under the modified binary search pattern. So LeetCode medium. Let's go. We have a sorted array, integer array numbers, and an integer value target. The array is rotated by some arbitrary number. Search and return the index of target in this array. If the target does not exist, return -1. Okay, so this is an original sorted array before the rotation. After you rotate it 6 times, yada yada yay, the end from 176 to 222 goes to the beginning like so. Awesome. So in this case, we're looking for 2. 2 is over here, so, and the index is at 0, 1, 2, 3. So we return 3. 199 is over here, 0, 1, 2, return 2. 8 does not exist here, so return -1. Fairly straightforward. All right, this is what the solution looks like. We initialize our 3 pointers, low, medium, and mid and high, similar to the last problem. And we compare the values of low, medium, and high. If the value at medium is less than high, we know that the section from mid to high is sorted. So check if the target value lies in the section range. It does not, because we're looking for 200. It does not lie here. We search between the low and mid pointers. The problem space cuts down to here. And yeah, discard everything to the right. Update your mid pointer once you've updated your high pointer. Then compare the values of low, medium, and high. Since the medium is bigger than the low, we know that low to mid is sorted. Check if the value lies in this section, and it does. Cut the problem space again. So you move high to index 3, I believe, yeah, and then recalculate mid. And now mid is bigger than low, so we know that low to mid is sorted. Does the value lie there? It does not. So we're going to move low to 1 after mid, I believe. Yep. Recalculate mid. Since mid is less than high, it's sorted. Again, this is a LeetCode medium, so it's not as easy as the last problem. But you will see the code, 2 angles to the code, a recursive one and an iterative solution. So if the target value lies in the section range, as it does, we search between mid and high. In this case, high is gonna we're gonna update the low pointer. And that's all. We found what we're looking for. Again, remember, it's a modified binary search pattern. So we start from low, we have end that initialized to the end of the array, like this. In this case, using end, they used high here. And we're gonna have the same type kind of loop. While low is less than high, we find the mid, same way as last time, the last video. If the thing at mid is what we're looking for, return mid. Everything happens here within this while loop. Just down a bit more. Okay, so then we find out that low to mid is sorted over here. This solution relies on this fact. At least one half of the array is always sorted. So if the array is rotated by less than half of the length, the second half will be sorted. Otherwise, the other half will be sorted. So it lends itself to binary search. This check here lets us know that low to mid, the current low to mid is completely sorted. So we can update things here, pretty much update high or low here, depending on what we want. So if the target is bigger than what's at low, and the target is less than what's at mid, so it's inside, because again, it's sorted, right? So it only has a chance of ever being either one of these cases, right? So far, it's sorted. Update the high to be within that window. So in our case, sorry, kind of throwing you all everywhere. We see that we're looking for a 200, and we know that these here to here is sorted, mid to high is sorted. So we're actually in this branch at first, where what's at low is not less than what's at mid, right? So this doesn't break, this doesn't happen. This instead happens. And what's at mid is not less than the target, and the target is not less than what's at high, because we're looking for 200, and 4762 doesn't check out. So nothing, so this doesn't happen. This branch here doesn't happen. Otherwise, this happens. High moves to mid, -1 moves to 8. And that's why high moved to 8. And then we're at the end of the loop, the first loop. So we come again and recalculate mid. That's why mid wound up here. I hope that makes sense. I hope that makes sense. Again, it's a medium problem. Sorry, I rambled earlier in the beginning. I was a bit tired, but I have to get the video out. So we check again, the same thing pretty much. What happens this time? So number indexed at low, is it less than what's at mid? Yes, that is true. So for once, this branch happens. However, what's at low, is it smaller than what's at target? Yes, that is true. And is what's at target less than what's at mid? Yes, that is true. So for the first time, this branch happens. So high is going to move from mid, so from where it is to mid -1. So high is going to move from here to here, to 3, like we can see. And then the loop goes again, recalculates mid, and so on and so forth. Lots of branching, but you get the gist, hopefully. This is not something I recommend you memorize. I recommend it's something you can try out, right, in a Scratch or REPL of some kind with sample data to figure out how you're going to branch things out and what conditions you're going to check. You just need to remember that you need to discard certain sections of the array and always check, perform this modification to binary search where you check, you find out what part of the array, what half of the array is perfectly sorted, because there's always a part that's perfectly sorted in a rotated array. And that's all there is to this problem. I would say it's still an O of log of n, but let's find out for time complexity. And I leave the recursive solution in the GitHub repo. Yep, log of n. And space complexity is O of 1. O of 1 because for the iterative approach, because we only ever keep the low, mid, high. We only ever store 3 things to solve this problem. But oh, the recursive has log of n. So number of elements present in an array, and log of n is the maximum number of recursive calls needed to find the target. Ah, I see. Because everything is being added to the stack, the call stack, and those old references are still there. So you are duplicating things consistently by doing that. So yeah, the iterative solution is more space efficient. There you have it. There you have it. Search in a rotated sorted array. Goodbye.